All right, so z-scores are a necessary feature of the normal distribution. Z-scores are used to measure how far away a data value is from the mean in terms of standard deviation. And this is only for data that follows a normal distribution. If your data is not normally distributed, you cannot use this specific z-score formula. Okay, so let's go through this again. So it is a measure of how far away a data value is from the mean in terms of standard deviation. So it's telling us how far away the data value is from the mean in terms of standard deviation. So how many standard deviations away from the mean are we? When we calculate a z-score, we're doing something called standardizing. And that's really important because we can use z-scores to compare things that have different means and different standard deviations. So the formula for a z-score is z equals x minus mu divided by sigma. As a reminder, x is our data value. So this could be any data value, any number within the population. Mu is the population mean. And sigma is the population standard deviation. Right now we're working with the assumption that we know mu and sigma and that we are taking data values from the entire population. If samples get involved, it gets a little more complicated, and we will look at what happens to all of this when we take a sample later. That's coming. Not right now. Keep things a little bit simpler for now. So let's look at some examples, do some calculations. So in a particular city, the average time it takes to commute to work, or the mean time it takes to commute to work, is 35 minutes with a standard deviation of 8 minutes. Find the z-score for the following commute times. So the first one is 45 minutes. So to calculate this z-score, let's identify some important pieces of information. So the average time it takes to commute to work is 35 minutes, and the standard deviation is 8 minutes. And then for this first one, we want to do 45 minutes. So in this first example, our x value is 45, our mu is 35, that's the average for the city, and our standard deviation is 8. So setting up my z-score formula, I'm going to do 45 minus 35 divided by 8. Now I want to make sure when I do this calculation that I do the subtraction before the division. So I tend to throw the top part in parentheses just so that I remember that that piece comes first. And then I can also put it in parentheses in my calculator, and then I can type it in all at once and I will get the correct answer. If I don't want to do it all at once, I can separate it, and this would be 45 minus 35 is 10 divided by 8, and that gives me 1.25. So if your commute time is 45 minutes, that means your commute is 1.25 standard deviations above the mean. That's what this tells us. Let's look at another one. The next one, the commute time, is 15 minutes. So for this one, our x value is 15. Our mu is still 35. And our sigma is still 8. So z equals 15 minus 35 divided by 8. And again, I'm going to put parentheses around the top. 15 minus 35 is negative 20. Negative 20 divided by 8 is negative 2.5. So this commute time is 2.5 standard deviations below the mean. And I know that this one is below the mean just by looking at it for two reasons. One, 15 is less than 35. Secondly, my z-score is negative. And I have one more here. My x value this time is 60. Whoopsies. X equals 60. Mu is still 35. And sigma is still 8. So z equals 60 minus 35 divided by 8. I'm going to do this one all at once in my calculator. So parentheses 60 minus 35 parentheses divided by 8. 3.125. So this commute is 3.125 standard deviations above the mean. So I have a empirical rule chart, a blank normal distribution. We're going to label where these z-scores would fall on this chart. So in the middle, this is where a z-score of 0 would be. If your commute was equal to 35 minutes, your z-score would be 0. Here is 1, 2, and 3. On this side, we have negative 1, negative 2. My handwriting's getting really bad. Negative 2, and negative 3. And we actually have marks for 4 and negative 4 as well. Typically, we only need to go to 3 and negative 3, but this one goes all the way out to 4. That's nice, actually. All right, so the first one we did was up here in blue. That was the commute time of 45 minutes, and it had a commute or a standard deviation of 1.25. So that's going to fall between 1 and 2, and it's going to be a little bit closer to the 1 than to the 2. That looks good. So this is z equals 1.25. The next one I did in green, and that was for x equals 15 minutes, and we ended up with negative 2.5. So now because it's negative, it's going to go on the left side of the middle, and it's going to go halfway between negative 2 and negative 3. Negative 2.5. And then our last one I have in pink. Our x value was 60 and our z-score was 3.125. So it's going to be pretty close to the 3. And I'm going to label this one up top. And I didn't put the z on this one. There we go. So this is our chart and how we can label the z-scores on the chart. And we can see, for example, this first one, 1.25, here's one standard deviation, and then we have a little bit more to get to that first z-score. The second one, here's one full standard deviation, here's a second standard deviation, and then we're halfway to a third standard deviation. And if I had labeled this chart like I would have done with an empirical rule problem where I put 35 in the middle and then did my adding of 8 and subtracting of 8 and put the actual x values, they would have landed at the exact same spots. And that's something that you are more than welcome to do to see how that lines up. So this is how we calculate a z-score and how we label the z-scores on a normal distribution curve.